For the homework tonight, we're just practicing a little bit of what we did in each example in the notes. So you can use your notes to help you too. Plot each complex number in the complex plane. So the real part, remember this is the real axis, horizontal, and the imaginary is the vertical axis. So if we've got -2, we go left 2, and then plus 4i is up here. So here's point A. Point B, if it's 0 minus 3i, if there is no real part, you're just going down 3 units on the imaginary axis. So there's B. Again, ignore this little point here. That's just a clip. I took this from somewhere and I didn't see that little point there. If it's just a real number, then we only go 1 on the real number axis and 0 in the imaginary direction. So there's point C. And this last one is -3.5 and then up 2.5. Oops, up 2.5. So you'd be like right here, and that's point D. Okay, write each complex number in polar form. No calculator for these. Okay, so remember, for these, we need to find R, find theta, write polar form. Remember, polar form is Z equals R times the quantity cosine theta plus sine theta times I. I don't care if you write I sine theta or sine theta times I. Excuse me. I think it's technically correct to put the sine theta in front, but it just looks weird with an I on the end sometimes. Okay, so let's see. R is equal to the square root of -1 squared is 1 plus 1 squared is 1. This is A, this is B, remember? So we get radical 2. The tangent of theta is equal to 1 over -1. Tangent is equal to -1 in 2 quadrants. Let's see where this point falls. -1 plus I would be in quadrant 2. So I'm just going to give the quadrant 2 angle. Reference angle is pi over 4. In quadrant 2, that's 3 pi over 4. So this is enough information to write my complex number in its imaginary, or in its polar form, excuse me. So we start with R, radical 2. And then the A component will be cosine of 3 pi over 4 plus sine of 3 pi over 4 times I. It's really tempting, because we've been doing this like all semester, when we see a trig function like this, to start simplifying it. But remember, if you start simplifying this and working on it, you're going to get yourself back to rectangular form. So leave it like this. It's kind of like we're unsimplifying the problem. All right, for the next one, R is equal to the square root of 4 squared is 16. 4 radical 3 squared is 4 squared, which is 16, times radical 3 squared, which is 3. 16 times 3 is 48. So that's radical 64. So R is 8. The tangent of theta is equal to 4 radical 3 over 4, which is just radical 3. This could be quadrant 1 or 3, so let's see where the complex number falls. If you go right 4 and up 4 radical 3, you should be in quadrant 1. So the quadrant 1 angle that makes tangent equal to radical 3 is pi over 3. All right, and now I have enough to write the complex number. So Z is equal to R, which is 8, times the cosine of pi over 3 plus the sine of pi over 3 times I. All right, next one. R is equal to the square root of squaring negative radical 3 makes it positive 3, plus squaring -1, you get 1. R is 2. Tangent of theta is equal to -1 over negative radical 3, which is just 1 over radical 3. Now, which quadrant are we in here? If we go left radical 3 down 1i unit, then we're in quadrant 3. So I'm going to give the answer in quadrant 3. Now, the reference angle is pi over 6, so this is going to be 7 pi over 6. And now the complex number is R, which is 2, times the quantity cosine of 7 pi over 6, plus sine of 7 pi over 6 times I. We talked about this in the notes. I think you can use pi over 6, and then you'd have to make this negative 2. Same thing here. I think you could have, for number 6, I think you could have used the quadrant 3 angle, so you could have said 4 pi over 3, but then you make this negative 8. Or back here, you could use the quadrant 4 angle, 7 pi over 4, but then you would make it negative radical 2. So there are different numbers, different options that would simplify to the same complex number. Now in this one, I'm going to use a calculator because we will not get nice common angles, but it's the same idea. So I'm not going to use a calculator to find R. I want to leave R in its exact form. So the square root of 9 plus 16 is just square root of 25. So that's 5. But then I get tangent of theta equals negative 4 over negative 3. So tangent of theta is 4/3. So theta is the inverse tangent of 4/3. And that's what I need my calculator for. Let's round these to 3 decimal place accuracy. That's what we do on our AP exam. We do that for pre-calc and calc, by the way. So let's make this 0.927. That's how many radians theta is. And then we still just write z as r, which is 5, times the cosine of 0.927 plus the sine of 0.927 times I. So it's a little tedious, but like these are such easy problems once you know the formula that hopefully these will just be nice, easy problems. Hopefully we get a couple on our AP exam. So this is the square root of 1 squared plus 5 squared. Square root of 26 does not simplify. It's 2 times 13. Neither of those are perfect squares. Tangent of theta would equal 5 over 1. So theta is the inverse tangent or arctangent of 5. Inverse tangent of 5 is 1.373. Again, that's a number of radians we're being given. So this complex number in polar form is square root of 26 times the cosine of 1.373 plus the sine of 1.373 times I. And final one of these, r is equal to the square root of 36 plus 9. That's the square root of 45, which does simplify, 3 radical 5. Tangent of theta would equal 3 over 6. Didn't we just do this one? Let's take a look. Or was that in the notes? Oh, that might have been in the notes. Okay, so I'll do it again. So second tangent of 1/2 is 0.464. So theta, that was inverse tangent of 1/2. That was about equal to 0.464 radians. And so z is equal to 3 radical 5 times the cosine of 0.464 plus the sine of 0.464 times I. All right, we're back to no calc. Write each polar form complex number in its rectangular form. So remember, these are the easy ones. You're just trying to get z equals a plus bi. So basically just do math. Simplify these like we would unit circle trig and then see what you get. So start on the inside. Cosine of 7 pi over 6. So the cosine at pi over 6 is radical 3 over 2. This is in quadrant 3, so we're going to be negative radical 3 over 2. And then sine is also negative, so minus radical 3 over 2 times I. When we distribute the 10 through, we get negative 5 radical 3 minus, sine of 7 pi over 6 is negative 1/2, not radical 3 over 2. Okay, so we get, when we distribute the 10 through, we get negative 5 radical 3 minus 5 times I. So these are easy ones unless you do the math wrong, and then you feel silly. Okay, so then this one is same idea. Negative 4/3. cosine of 5 pi over 3. So the cosine of pi over 3 is 1/2. 5 pi over 3 is in quadrant 4, so cosine's still positive 1/2, but sine's negative radical 3 over 2. Distribute the negative 4/3 through. So it's always a good time to test our fractions here. Negative 4 over 2 reduces, so this is negative 2/3. This is going to be plus, again, 4 over 2 reduces, radical 3 over 3 times I. And that's our final answer for number 12. All right, that finishes this worksheet. Come on into office hours if you have questions about any of this or want more practice.